Alright, so in this video, I'm going to solve the equation 2 to the power of x is equal to x to the power of 32. So, to solve this, I'm going to first start by taking the power of 1 over x on both sides. So I get 2 to the power of x to the power of 1 over x is equal to x to the power of 32 to the power of 1 over x. And the reason I did this is because if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So x and 1 over x, these two cancel out. So on my left-hand side, I just have 2. And for my right-hand side, 32 and 1 over x multiply to get 32 over x. Now, from here, I'm going to take the power of 1 over 32 on both sides. And if you guessed, we're doing this to get rid of this 32 on my right-hand side. So for my left-hand side, I just have 2 to the power of 1 over 32. Now for my right-hand side, these two are going to cancel out. So I get x to the power of 1 over x. That's all that's there remaining. And now, we want to simplify this because our end goal is to make this in the form a to the power of 1 over a is equal to b to the power of 1 over b. So in that case, if that's in the form, that means a is equal to b. So we already have x to the power of 1 over x over here. So we just need to make the left-hand side be in the form a to the power of 1 over a, meaning this number here has to equal this number. So we need to find a way to make that. Well, what we can do is rewrite 1 over 32 as 2 over 64. And now, remember, this is the same thing as if I have something in the form a to the power of n to the power of m, this is equal to a to the power of m times m. So I can reverse this and rewrite this as 2 to the power of 2 to the power of 1 over 64. And 2 to the power of 2 is 4, so I get 4 to the power of 1 over 64 is equal to x to the power of 1 over x. Now, this still isn't, these two numbers still aren't the same. So what we're going to do is repeat the process once again. 1 over 64 is the same thing as 2 over 128. And I can rewrite this as 4 squared to the power of 1 over 128. Now 4 squared is 16, so I get 16 to the power of 1 over 128 is equal to x to the power of 1 over x. And they still aren't the same, so I'm going to repeat it once again. So I get 16 to the power of 2 over 256 is equal to x to the power of 1 over x. Now this is the same thing as 16 squared to the power of 1 over 256 is equal to x to the power of 1 over x. And now 16 squared is equal to 256. So I get 256 to the power of 1 over 256 is equal to x to the power of 1 over x. And now notice that these numbers are the same, and this is in the form, as I said, a to the power of 1 over a is equal to b to the power of 1 over b, meaning a is equal to b, so x is equal to 256. So this is my solution to this equation. If you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family. Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5, and this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25, and this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125, and this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides, so I get log phi to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log phi to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer.